Now look at the lines on top of me. Going from A to B, all right? The first one goes around in circles or, curves. The second one going from A to B is just a straight line. It's the simplest way, right? Same with our algebraic expressions. Sometimes they're too long, too difficult, but guess what? You can simplify them. And how will you simplify them? You will use the properties of expressions, and also that includes combining like terms. So that's the lesson for today. So first of all, we need to review the properties. These are properties which we have learned in the past. Okay, what are these properties? These properties include commutative property that works for addition. Remember, the order doesn't matter. Commutative property also works for multiplication. Switch them, they are always the same. Remember that. Next, we learned about associative property. Associative property works for addition and multiplication. You can add any order, series of addition, it doesn't matter. You can multiply in any order, the first two or the last two, it doesn't matter as long as they're all multiplication. What else? We've learned about distributive property, right? Distributive property of multiplication is distributed to each of the what? Each of the terms inside the parentheses. Look at this example, okay? Addition property of addition, identity property of addition, the answer is always the same. Just add a zero. Identity property of multiplication, the answer is always the same. Just multiply by 1. Okay, look at these examples. And what else? Inverse property of addition, add the opposite and you'll get a 0. What else? Zero property of multiplication, multiply any number by 0, it's always a 0. Remember all these properties because it will make our expressions easier to understand. So the objective of this lesson is to examine expressions. We will look at expression. Yes, they may look different, but they are actually equal to each other. All right? For example, you see a x minus 5. Don't be scared when you see negative 5 plus x. Guess what? They are the same. This expression is the same with that expression. Okay? How will I know that? Because of the properties that you've learned. And what else? How do I check if they're really equal? You will substitute a value for any variable. All right? So that means you will evaluate. Evaluate. Are you sure that the reverse of this is the same with that? Oh yes, let's try to substitute. For example, if x is equal to, let's say, 10. So let's plug it in. 10 minus 5, is it equal to negative 5 plus 10? All right, the answer on the left side is 5. The answer on the right side is 5. If both values are equal, then therefore, we are sure they're the same. Okay, let's move on. Now, in real life situations, sometimes RAM would give you a problem and different kids would write different expressions, okay? But don't worry, even though they're written differently, they all mean the same. For example, a computer was 1,500, but it's on sale with a 35% discount. What expression can we use to solve for the sale price, all right? So look at the first part, multiplying by 0.35. We remember that, right? To get the discount. And then once you know the discount, we subtract from 1,000. This is the regular way, the traditional way that we've been doing it. But guess what? Other students might write it in different ways. Remember this? Instead of using 0.35, I use 0.65. Yes, that's the shortcut, and you will automatically get the selling price. All right. So if I reverse this one and that one, what property is that? That's commutative property. Definitely, I'll get the same answer. Now, for example, 0.65 divided by 65 divided by 100 is actually 0.65. Same thing, right? Then multiply by that, so it's the same thing. All right. And lastly, 35 divided by 100 is 0.35. That's the same as this. multiply by 1,500, that's the same as that, and then subtract it, then you'll get your correct answer. See? Different expressions, but they're all equal. And I know it because I know the properties of expressions, properties of equations. Okay, so let's start with this expression. We want to see which shorter expression would be equal to this. Okay, so don't be scared. It looks long, right? But I can simplify it. Remember your rules? See, your distributive property can help you first. You could do what? 2a plus 4b, right? That's a distributive property. Copy what you didn't use, minus a minus 2b. Next, let's combine the like terms. 2a and minus 2a are the same like terms, meaning, and then I mean that becomes 2 minus 1 is a 1a, or simply an a. What else I can combine? Can I combine positive 4 and negative 2? 4 minus 2 is a positive 2b, right? But normally we don't need to put the 1, so a plus 2b. So we know that this is the correct answer. Now, let's prove that it is correct. Okay, easy to prove. Use any value. Suppose a is equal to 1. Let's make it easy. And b is equal to 2. All right, let's substitute then. So, ready to substitute? This substitute now, that becomes 2 times 1 plus, this becomes what? 4 times b. B is now a 2 minus a, and my a is what? 1. And then minus again 2 times b. 2 times and my b is 2. See? So now let's multiply first. 2 times 1 is 2 plus 4 times 2 is 8 minus 1 minus 4. I move from left to right. This will become a 10 minus 1 minus 4. This becomes a 9 minus 4 is equal to 5. See? That's a value of 5. Are you sure it will also be a 5? If I substitute these numbers to my simplified expression, let's check then. If my a is equal to 1, I write 1 plus 2 times b. My b is a 2, right? So 1 plus 4 is a 5. See? They are the same. So guarantee that this is what? Equal to the original expression. Actually, you don't need to evaluate. That's just to check whether you're really right or wrong. And where did I get the value of a equals to 1 and b is equal to 2? You determine it. Use simpler numbers so that you can easily substitute. Now we have the reverse. Which expression is equal to 1/3 y? This is already very simple. Simple. And what do they have here? They have long expressions, which I don't know what the final expression would be. All right, therefore, let's try everything. Let's try the first one. That's 1/3 y. And then 1/3 times 12. 1/3 of 12. 1/3 times 12 is 4 minus 12, right? Okay. 1/3 y, 4 minus 12 is a number already, right? That's a negative 8. 1/3 y minus 8. Definitely, that's not the same as the original. Let's try the next one. 1/6 y, and then I could do distributive first. Do the distributive first. Plus 1/3 y plus 1/3 of 3 is a 1 whole, right? Okay, 1/3 of 3 is 1 whole. Next, 1/6 plus 1/3. Let me change 1/3 so that they're going to be the same. I'll make you 2/6. All right, now I can add it. That becomes 3/6. 3 over 6y plus 1. That's totally different from the original one. So forget that. How about the next one? Let's do our distributive. Okay, let's copy the original first. 1/6y, 1 plus 1/6y. All right. and then 1/6 times plus what? 1/6 times 12. 1/6 of 12 is 2. All right, just multiply them. And then minus 2. Okay, what's next? 1/6 plus 1/6 is 2/6. 2/6 y. These two will cancel out. There's no more variable. There's no more constant. But is 2/6 equal to the original? Yes, the lowest terms is 1/3. So I can stop now and definitely choose that as my answer. Okay? All of this. Easy, right? Next. A store has a 20% off sale. The item of the price of P, which expression can find the sale price of the item? All right. So it was originally P. Okay. So less 25%. Okay, let's look at the first one. Multiply 25% by P and then subtract that from P. Yes, that's the normal way. So that's right. Multiplying by 0.25 is just the discount. You want to know how much you will pay. So not you. Multiply by P. Why will you add it? So that if you add, the price will be bigger, right? So definitely not. Why will you multiply by a negative? No. All right, so you took away the 25%. You took it away. Therefore, you're paying the 75%. Multiply it by the P. That works. 1.25 will make the price higher. All right, so not you. Okay, 1 plus 0.25 is 1.25. That's the same thing, not you. If I subtract 1 minus 0.25, I get 0.75. Multiply it by P. I think we did that a while ago. That's the same as this one. The same as this one. Therefore, this is correct. See? Different expressions, but these three, only these three, are equal to each other. All right, so we need to know which of the following is equal to this. So let's do it one at a time. 5 times x is 5x. 5 times 15 is 75. All right, are they the same? No. Next, let's try the second one. 5 times x is 5x. 5 times negative 3 is negative 15. Exactly the same. Awesome. Next, combine the like terms. 4x and the x could be combined as what? That becomes 5x. All right. How about the y's? I can combine this positive 3y and negative 3y. You don't need to combine. That becomes a 0, right? So the remaining number left is minus 15. Add it up, minus 15. There you go, the same. Next. Easy, right? Let's try the next one. We have 7x negative and negative 8y. So negative and negative, negative 15y. You don't need to continue because there is no y in our original expression. So forget that. Okay, next. The x and the x can be combined. So 8 minus 3 is a 5x. All right, next. Look at the negative 20 and the positive 5. Different signs subtract. That's a 15 because 15 is a greater absolute value minus 15. So that's also correct. So these three are the correct values equivalent to the original one. Okay, this should be the last. Now, how many like terms are in the expression? Okay, you just want to know how many are the like terms. Your like with this one and that one. Okay, like terms with this. Okay, that's one. And what else? I think that's the only one, right? So that's the only one with like terms. And how many terms are there? There are 3. Okay, so that's it, guys. So that's our Rampage math lesson for today. Remember, Results is equal to action plus motivation. Good luck.